So here we are, it's an electricity question. A heater, an electric shower, is used to power 8.5 kilowatts, so straight away I can see there's going to be a bit of a trick there with the prefix. When connected to a 240 volt electrical supply, it is connected to the electrical supply by a copper cable. Then it's given us some information about the copper cable. There's all kinds of issues here with the prefixes, but let's just go on to the next question. So this question says, calculate the current in the copper cable. It's worth 1 mark. We've previously been given power, we've been given voltage, so the equation which links these two, P equals I V, we want I, so P over V equals I. So in our case, the only trick is this prefix of 10 to the power 3, so it's 8.5 times 10 to the 3 over 240 volts, which would give us a value of 35 amps. The next question, it says calculate the resistance of the cable. So we've been given all kinds of parameters here for our resistance. We've got length, cross section and resistivity. So straight away we're going to be looking at the resistivity equation, where R is equal to the rho times the length over the area of the particular cable. So we've got resistivity is in meters, area is in millimeters squared in meters, so we're going to have to make sure we're working in the correct SI unit. So our resistivity, 1.7 times 10 to the 8 times by the length, which is fine, it's in meters, 10 meters, and the big problem comes in area. Everyone always makes this mistake. They think because it's millimeters, we know millimeters conversion out is divide by 1,000, and people only divide by 1,000, but actually it's millimeters squared, so we divide by 1,000 divide by 1,000, which is actually 1 times 10 to the minus 6. Therefore, coming through, this will be 6 times 10 to the minus 6. That's the classic mistake with the area. Fire that into the calculator, and that will give us an answer of 0.028 ohms. 2 marks. Then it says, explain in terms of electrons what happens to the resistance of the cable as the temperature increases. So that's specific. It wants to know what happens to the electrons when the temperature goes up. What happens to the resistance because of this? So what happens? Well, as the temperature increases, what you're actually getting here is you're getting vibration. That's all temperature is. It's this increase in vibration. So temp goes up, vibration goes up. And as a result of this, you're going to get more